In this video, I'm going to basically just describe integration factors for a linear first order differential equation, which is in this form. With capital lambda as the integrating factor, we'll multiply that by lambda, and in this case we set the equation in a symmetric form, so we get it in the form of p of xy dx plus q of xy dy equals 0. So we get it in this form basically, and we now have p and we have q. So we set the integration factor such that the partial of this coefficient with respect to the other variable is equal to the partial of this coefficient with respect to that other variable. So in this case, the differential of lambda with respect to dt will be equals to negative of the differential with respect to y of this thing. So in this case, this is a function of t, so it's treated as a constant, so it goes to 0, and the only term that survives is this term. So we differentiate and we find the relation over here from t0 to t, and we define t0 to be our basically initial value, so like this, right? So we also, now that we know that what the lambda is, we take it and multiply it to the original linear equation, and you get this. And we want now to describe this term over here, lambda dy over dt. It's kind of weird. So basically all you can do is we can take advantage of the product rule. And how will we do that? Well, we take the derivative of lambda y respect to dt, which will be equal to lambda dy over dt plus y d lambda over dt. So if you solve for this, you get this relation. Additionally, once we look into this thing, plus lambda is equals to, we set that equals to the relation that we found over here. We use this relation over here. We say that lambda at is equal to negative of the differential of lambda respect to dt. And in this case, we defined the lambda to be solely a function of t. You did not notice, right? So we substitute that in, plus lambda ft is equals to the substitution that we did over here using this relation. So these two terms cancel out, and we get that the sorry, what do we do here? Yes, we get that the differential of lambda y respect to dt is equal to lambda multiplied by f of t. So we integrate both sides with respect to dt in this method. So we have the equation over here, we solve for y, and you get this function, you get this thing over here. Now, why is there a c and why is there a t0? Shouldn't there not be a c? Well, this is what kind of confused me, but I think that what he means is that he wants the c's and the t0s to cancel, because if you look at the lecture notes, he says that y at t0 is equals to y0, which we define to be c. Now what's kind of intrigues me, because I thought that, okay, because you're doing indefinite integrals, you don't have the need, you don't need to have the c, but in this case you do in the lecture notes. So that's what's kind of confusing for me, and I will post another video explaining it in a different method. I thought that this method was kind of interesting because you had to make use of the product rule and this relation and make a different kind of formula that's solvable. Anyways, that's it really.